Okay, so let's start today class. Today we are going to discuss battery, some advanced battery and molten solvent battery. Okay. So just first of all, share the screen. Okay. So today we are going to discuss battery. That means molten solvent battery, advanced battery, and role of carbon nanotube in electrodes. So what is the molten solvent battery? Molten solvent battery, liquid metal battery are a class of battery that use molten salt as an electrolyte. Okay. It offers both high energy density and a high power density. So a typical battery has a solid electrolyte membrane between the anode and cathode compared with the liquid metal. So in the previous class, we already discussed some other battery, that means some primary battery and classification of secondary battery. Okay. So under which we are going to discuss here. A typical battery have a solid electrolyte membrane between the anode and cathode compared with the liquid metal battery where the anode, cathode and electrolyte are liquid. So the best example of this cell is sodium sulfur battery. Okay. So molten solvent battery is one of the example is the sodium sulfur battery. So just try to see here how we can sodium sulfur battery charge and discharge. Okay. Sodium sulfur battery is a type of molten solvent battery. One of the type of molten solvent battery. The outside of the container, that means the liquid sulfur, serve as the positive electrodes, that means cathode terminal, while the liquid sodium serve as the negative electrode, that means anode. Okay. So as you may be seen from the name of this battery, sodium and sulfur. So sulfur act as the cathode terminal, that means positive electrode, and so sodium is your negative electrodes, that means anode terminal. Okay. We have in the basic explanation of battery, we say that the two electrodes, one is your cathode and one is your anode. Okay. That two plates are separated with a dielectric medium. So here in the sodium sulfur battery, sulfur act as the positive electrode plates, that is cathode, and sodium as the negative electrodes, that means anode. Okay. So here the electrolytes is beta aluminum ceramic. This is used to separate the liquid electrodes material. That means electrolytes used for the two plates separated by the beta aluminum ceramics. Okay, so main three component of any battery consist two plate and one electrolytes separated these two plate by the dielectric medium. So their material is used as the electrolyte as the beta aluminum ceramic, and two electrodes that means positive electrodes and negative electrolyte are sulfur and sodium liquid. Okay. So these are two electrodes, liquid sodium and sulfur battery. Okay. So this is the construction of the sodium sulfur battery. That means this is your sodium. That means act as the electrodes, negative electrodes, and sulfur as the positive electrodes. Okay, between the electrolytes used as the beta alumina, and this is your flow of electrons. That means from this direction. Okay, negative to positive, and current flow from the this opposite to the flow of electrons. That means from this. Okay, so this is the source, power source. Okay, so how we can that material or liquid can be contained, so that we maybe find out in a cylindrical structure. That means this is placed here at the sodium, and this is uh, electrolytes separated of the two liquid, that means sodium and sulfur. Okay, so this is your beta alumina, and this is another cylindrical structure, that means sulfur. Okay, and maybe so in the one diagram, that means how we can placed in the container cylindrical structure. Okay, so inside, that means place here in the cylindrical structure sodium liquid, and below that cylinder where the sodium liquid placed, that means one safety tube you have to place, and then electrolytes, that means separated with this sodium and this sulfur. Okay, by the beta alumina, and this is your sulfur housing where electrodes, that means sodium and sulfur and beta alumina placed in a single cylindrical. So one by one construction, that means sodium and sulfur, and then electrolytes separated between them, that is beta alumina. How we can place that means in a systematic diagram, you will find out either in this way or in this way. Okay, this is the chemical reaction. How the sodium converted in sodium plus ion in the electrolytes, and with the Na2S, that means sodium sulfur. Okay, so this is all about the construction or placement of the sodium and sulfur, that is act as the one as the positive electrodes, and one as the negative electrodes. Okay, so you will find out, that means sulfur, that means your positive, that means cathode. Okay, and uh, sodium is your negative, sodium as negative electrodes, that means anode. So their placement something like this one. Okay, in a cylindrical structure, one by one you have to place in one cylindrical sodium, and after that one electrolyte safety tube and beta alumina. And so this is the explanation of the structure of the sodium sulfur battery. That means how we can place in the systematic diagram. The cell is made in cylindrical configuration. Whatever you may find out in the structure, that means this is nothing but a cylindrical structure. So you have to explain this one. This is your cylindrical structure where we have to put sodium and sulfur. Okay, and all the component what is required for the battery. That means the cell is made in cylindrical configuration. Their structure is cylindrical, and the entire cell is enclosed by a steel casting that is protected which is made by chromium and molybdenum. Okay, So generally the sulfur is very poor electrical conductor, and hence an effective current collector is required. Hence, sulfur is not a conductor material, so that may not able to flow the current. So we take graphite carbon in the form of felt, which is immersed in the sulfur liquid. Okay. So then the metal container provides the positive electrodes connection. The container is sealed at the top with an airtight aluminum liquid. Yeah. Great. So the essential part of the cell is the presence of base beta aluminum solid electrolytes membrane. That means the separation of the sodium and sulfur liquid. Okay. So this is the structure of chemical reaction of the sodium sulfur. That means which is selectively conduct sodium plus ion in commercial application, that the cell arranged in a block for a better heat conservation and are enclosed in a vacuum chamber. So you will find out here the positive ion, and this one is your negative ion. So negative electrodes current collector, this one is your current collector. Since sulfur is not a very good conductor material, so this is the sulfur immersed in the carbon felt. So and this one is your liquid. Okay. So the maintaining the high operating temperature, that means almost about 300 to 400 degrees Celsius. Okay. So and are the enclosed in a vacuum chamber. So their structure, how we can place the negative electrodes current collector, and a stainless steel can positive electrodes and beta aluminum. This is your beta aluminum. After that, this one is your sodium. Okay, this is structure. You will find out this one white one is your beta electrolytes, which separated the sodium and sulfur. So what is the during the charging and discharging of battery, that means sodium sulfur. So when a sodium sulfur cell is discharged, the sodium ion, that means Na plus ion, at negative electrodes travel through the base electrolytes to positive electrodes, where they react with the sulfur and forms the sodium sulfide, that means Na2S. Okay, so Na plus and negative electrodes make the reaction with the sulfur and form the sodium sulfide. The process is reversed when the cell is charged. So this chemical reaction can be represented something like this one. So during the discharging, that means 2Na plus S make the Na2S, that means sodium sulfide, and during the charging, this sodium sulfide make 2Na plus S, that means sodium plus sulfur. Okay, so this is the chemical reaction. However, the sodium sulfide interact with excess of sulfur at the positive electrodes to form polysulfide, that means Na2X. X is the range from 3 to 5, maybe S2 or S3, S4, S5. Okay, so here the value of X you may put as either 3, 4 or 5. Okay, so range may be vary from 3 to 5. Within the range, the Na2SX is soluble in the liquid sulfur, otherwise it separate and interact with the cell operation. So you may be kept their chemical reaction during the charging and discharging, how you can represent. So sodium and sulfur during the discharging make the sodium sulfide. Okay, their chemical formula can be represented as Na2S. So the battery voltage is 2 volt. The specific energized are in the range of 200 to 300 watt hour per kg. This battery has a high energy density about 150 to 250 watt hour per minute. Okay, so it has zero discharge or excellent charge retention. Remember the charge, this battery during the charge. So charge retention is excellent, and also it has a high recharge efficiency, almost about 85% can be charged in 3 hour rate. So potentially 5 to 10 year life for the sodium sulfur battery. You may find out. Okay, so almost you may be use this type of battery up to 5 to 10 years. Once the running the heat produced by charging and discharging cycle, hence no external source is required. Okay, if you put charging and discharging cycle, so no external source is required after that. So what is the application of sodium sulfur battery? You may find out the sodium sulfur battery application in various fields, just like as a automobiles, transport vehicles, and aerospace and electric vehicle, where you can use the sodium sulfur battery. Okay, so I think this application is very popular for this sodium sulfur. That means in automobile sector, transport vehicle sector, and aerospace and electric vehicles. Next is our what the advanced battery. This is all about the sodium sulfur battery. Okay. And the research and development aim at lesser cost and better specification. So characteristic than conventional lead acid nickel cadmium battery. Advanced battery are simple electrochemical energy conversion with easily available with the cheaper material. So some advanced battery operate at the temperature just like a sodium sulfur. Some advanced battery are use flowing electrolytes. Additional subsystem are necessary to maintain the temperature or flow in the models. So advanced battery becomes economical in large size. So they are used in large energy storage application only. The conventional battery will continue to economically attractive in a smaller size, but in advanced battery you may find out their application for the larger size, economically cheaper also. Okay, so this is the basic difference, or you can say that between the conventional battery and advanced battery. Conventional battery may be used for the uh, smaller energy storage and where we required, but if you want to store a large energy with economical, then we have to some specific change with the material compared to the conventional battery. Okay, so we are able to economically cheaper and stored energy larger compared to the conventional battery. Some important advanced battery example here we mentioned, that means some may find out sodium sulfur, one of them, zinc chloride, zinc bromide, zinc silver, and zinc nickel. Okay, so these are the advanced battery where you may be use various type of material for the electrolytes, positive electrodes and negative electrodes. That means cathode and anode. So what we try to see this sodium sulfur, and next one by one we try to explain this one, zinc chloride and zinc bromide and zinc silver. Okay, and zinc nickel last one. So first one is sodium sulfur battery. So this is the type of molten solvent battery we already explained few minutes earlier, which is constructed by anode by the sodium and cathode positive electrodes with liquid sulfur, and electrolytes aluminum oxide yellow. Okay, the cell full charge voltage is almost 2.21 volt. So the operating temperature is 300 to 400 degrees Celsius, and it has energy density and efficiency 85%, and it has long life. Okay, that means 5 to 10 years. We already mentioned few minutes earlier. Okay. So these are the specific material used for this sulfur sodium battery. Okay, you have to concern about their anode and cathode terminals and electrolyte material. Okay, same things you maybe find out in the other types of battery. That means next one is before that we just electrochemical reaction. This one is we already explained few minutes earlier. Okay. These things. Next one is zinc chloride. So in zinc chloride, that means which is constructed by the material difference. So you maybe find out at the anode, that means we use as the zinc, and cathode for the positive electrodes we use chloride. That means represent chlorine by Cl and zinc by Zn. So electrolytes material zinc chloride. The cell full charge voltage range or up to approximately 2.4 2.1 volt, and operating temperature is range from 20 to 30 degrees Celsius. Okay. The energy density is high of the zinc chloride. So these are the material for the zinc chloride. Okay, that means we have to use zinc for the anode terminals and cathode for the chloride. Okay, and next is our electrochemical reaction for charge and discharge. Okay, so we see here that anode for the zinc and cathode for the chloride we have to use. Okay, so we already explained this one. Next is our next that is our electrochemical reaction for the zinc chloride battery. That means Zn plus chloride. That means during the discharging, make the zinc chloride. Okay, and when the charge this one, so zinc chloride make the Zn plus Cl2. Okay, so this is the battery for the zinc chloride, where the Zn used for the anode and chloride used for the cathode. Okay. Next one is zinc bromide. So anode plate is same as the zinc, and cathode material in here, that means we use bromide. Okay. So for the positive electrodes we use bromide, and zinc as the negative electrodes. That means for anode and electrolytes zinc bromide. That means ZnBr. So the full charge of the cell is 1.8 volt of the zinc bromide, and the it has high energy density, also same as the zinc chloride. So next one is zinc chloride. So chemical reaction of this zinc chloride bromide, that means during the discharging, you have to keep in mind the chemical reaction also of the all individual battery. Whatever we discuss here, that means zinc chloride, sulfur, sodium sulfur battery, zinc chloride, zinc bromide. Okay. So chemical reaction for charging and discharging is Zn plus Br2. During the discharging make the zinc bromide, and during the charge period, when the battery charge, so make this ZnBr. This is the reversible process. Okay, so, that means from the ZnBr2 to the Zn plus Br2. This is the structure for the zinc bromide. Here we place, that means bromide, and this is your zinc. That means lead AC source of this one, and next one is our zinc silver. Okay. Next is zinc silver. So here for the in the zinc silver, which is constructed by the anode terminal by the zinc, that means again here, but cathode material we change, just in place of bromide we use silver oxide. Okay, so and electrolyte NaOH, sodium hydroxide, or maybe use calcium hydroxide. So the cell full charge voltage is for the silver zinc silver bromide zinc silver battery is almost 1.6 volt. It has high energy density, that is 100 watt hour per kg. Okay. So you have to just concern about their anode and cathode material for the various type of battery, whatever we discuss here. Okay, that means so which are the various advanced type of battery: zinc silver, zinc bromide, and sodium sulfur. So their material position changes, just anode and cathode material. Okay, and the zinc silver battery has the chemical reaction during the charging and discharging, just same as this one. That means during the discharge, that means Zn Ag2O, make the ZnO zinc oxide plus 2Ag and silver. Okay, but during the charging, so this one is make as the zinc and silver oxide, okay, Ag2O. So this is the structure where we placed as the zinc at the anode terminal, and this is your separator, this one. Yeah. This is your top cap, and this is your structure for the zinc silver battery. Okay. So next, if we discuss about zinc nickel. Okay. So again, the anode material is same, since the zinc is used as the anode. So constructed this type of battery, zinc nickel anode for the zinc material, and cathode with nickel oxide, that is NiO, and electrolytes, that means hydrogen alkaline. And the cell full charge voltage is 1.6, and the energy density is 100 watt hour per kg. So you must be remember their specific material for zinc nickel, zinc silver, and sodium sulfur, whatever the charge voltage level. Okay. Uh, and energy density also. So you have to keep in mind all these parameters for the various type of battery. Okay, whatever we discuss here. That means so this is all about the battery and the chemical reaction for the charge and discharge. That means zinc nickel battery. Okay. So during the discharge, Zn nickel oxide, that means NiO, make the zinc oxide plus nickel. Okay, and during the charging, make this zinc plus nickel oxide, ZnO plus Ni. So this is a reversible process, and this is the structure for the zinc nickel battery. That means this one is your positive plate, and this one is your negative plate. Okay, and their material is used as the Zn plus 2 electron Zn. Okay, this one is your positive plate, and make the reaction through this potassium hydroxide, and this is your electrolyte of chemical reaction for the charge and discharge. Okay, during the charging and discharging period. So whatever battery we discuss here, you have to keep in their material, which one is act as the anode and which one is act as the cathode. Okay, and their electrolytes. Okay, and their voltage rating. What is the voltage rating up to which type of battery? Okay. So all these parameters you have to keep in mind for the various type of advanced battery. Okay. So what we discuss in the next is just so this is all about the various type of advanced battery, and next we will discuss role of carbon and nanotubes in electrodes. Okay. So carbon nanotubes were discovered in 1991. Carbon nanotubes consist of graphene rolled into the shape of cylinder. The carbon atoms of graphite is symmetrically bounded of three other carbon atoms. One atom is large, which form hexagonal rings, and these are categorized into two groups. Okay. So the role of carbon nanotubes electrodes. The carbon nanotubes consist of graphene rolled into the shape of cylindrical shape in cylindrical shape. So the carbon atoms of graphene is symmetrically bounded to three other carbon atoms. So one atom is large, which form hexagonal rings. Next, yeah. Single wall, multi wall. What is the single wall? That means single wall. We can say that the consist of these nanotube consist of only one layer of graphene, and multi-level wall. These nanotubes consist of many layer of graphene. So each group consists of complex mixture of tube of varying length, diameter, and crystalline structure, surface, chemistry, etc. So the metallic carbon nanotubes can produce electricity with a density that is 100 times greater than the commonly used metals such as copper. Okay, so this is the basic difference compared to the commonly used metal, copper, or between the metallic carbon. So for the use of carbon nanotubes as electrical component, there are many application. So if you use carbon nano. So the basic problem associated with the present electrochemical battery are limited their life is the main disadvantage. Okay, we can say that their life is limited and leakage environmental consequence. Okay, so these are the basic problem associated with the electrochemical battery in present time. So we just try to uh, work on the if we make the battery for the longer use. Okay. The carbon nanotubes can be used as anode for the lithium battery for improving the performance of anode design. Using carbon nanotube in battery to offer following benefits if you use nanocarbon. Okay, carbon nanotube. So increasing the available power from a battery and decreasing the time required to recharge a battery. So these benefits are achieved by coating the surface of an electrodes with carbon nanoparticles. So increasing the surface area of the electrodes, they are allowing more current to flow between the electrodes and the chemical inside the battery. Nanotubes can be used as a coating to separate the electrodes from any liquid in the battery. So when the battery is not used. Okay. In the current battery technology, the liquid and solid interact, causing a low level discharge. This discharge the shelf life of battery. So this decrease this shelf life of a battery because the current battery, liquid and solid interact with each other. So causing the low level discharge and this decrease the shelf life of battery. In this, there is no problem because they are extremely strong and stiff and relatively ductile. Okay. So this is all about the advanced battery and molten solvent battery and carbon nano tubes. Okay. So just we stop here and in the next class we will discuss another things. Okay. So just we stop here.